Yeah, people are back. Awesome. Okay. So today I'm going to try and convince you of something. And it could be a little bit controversial, but I want to try and convince you of this. I want to try and convince you that as a software engineer, we're not paid to write code. It's not your job. So who writes code for a living? Cool. Okay. The people that don't write code for a living, what do you do as a job, out of curiosity? Solve problems. Love that. Somebody else? Yeah. Brilliant. I feel like we all do that. So this interesting sentence has a couple of ambiguous meanings to it, which we'll cover later on. But there's two ways this can be interpreted, both of which I agree with. So before we get started, I'm just going to talk a little bit about myself. I'm not going to spend a long time on this because a lot of this talk is me talking about myself. So I'm not going to spend a long time on this. But like in the intro, I've been writing code for an incredibly long time. So my cursor on the way. I've been writing code since I was 8 years old. And I've been paid to do it for 13, 14 years. And I very quickly got into technology leadership. And it's something that fascinated me and something that I still learn a lot about today. To the extent where I now run a business focusing on technology leadership and how we can be better technology leaders by focusing less on the technology and more on the people around us. And some of that will go on to that. So, I said I started writing code when I was very young. I started writing code when I was 8 years old. Does anybody recognize any of these two devices? Yes?
BBC Micro?
Yes, anybody recognize the other one?
ZX Spectrum.
ZX Spectrum. Yeah. So I started writing code using these things. These things are amazing. So this is back in the days where computing monitors didn't even really exist. You plug these things into your television. You had an aerial cable that came out the back, and that went into your TV. And not only that, the way you stored the programs on these things is incredible. You used audio tape. Not backup tape, not that 10 terabyte backup tape. Audio tape. The same kind of audio tape you'd listen to your ABBA from. Just me. And the way you do this is you have your mum's audio recorder, your mum's tape player, plugged in with a 3.5mm jack. And you press save on the Spectrum. And you'd run to the audio recorder and you press record. And you'd hope you'd done it quickly enough, otherwise you missed the beginning and it didn't work. And then when you wanted to load the data, you do it the opposite way around. You press play on the tape player, and you run to the machine, and you press load. This is how I learned to program. I learned to program using these, and it fascinated me. The idea that you could do something on a keyboard, and it could make something else happen. This idea that we could automate tasks, we could make things appear, we could make games, we could make programs, we could automate everything we do. There's one last thing I want to point out about these, which tells you how old this technology is. This is the keyboard of the ZX Spectrum. Have you ever seen anything more confusing in your life? The reason why it's like this, there was only 16 kilobytes of storage on these things. 16 kilobytes, not megabytes, not gigabytes, kilobytes. And so if you were to store the computer programs as plain text as ASCII characters, it'd take up too much space. So they actually used a version of bytecode. And you could see this when you were typing it. If you wanted to type an if statement, you wouldn't press IF. You press U, because U has if on it. And an if will magically appear on the screen. And then you type the name of your variable. And then instead of typing THEN, you have to remember, I'm showing now. Where's that? Can everybody see that? No, I will say. You have to press the key that had there on it, and then N. And it stored all these things as single bytes in memory. It didn't have enough storage to store the words. This is how I learned to code. It's great. So, what programming language did they use? Basic. My first programming language was Basic. Beginner's all-purpose symbolic instruction code. Is that right? Yeah. Awesome. So, I learned to code using Basic. Great programming language for somebody that's first starting to learn back in the late 80s, early 90s. But of course, being ambitious, being interested, excited by this, I moved on to my next programming language, C++. As a 12-year-old child, this broke my brain. I could not get my head around C++. I couldn't, just pointers and references, and I couldn't do it. I spent about a couple of months trying to learn C++ and gave up, and then moved on to the next programming language that actually stuck. Does anybody want to guess what that was? No? Interesting. Good answer, but no. No, COBOL.
Modular 2.
No. So I'd started off with BASIC.
Visual
Basic.
VB6.
Yes. So I started learning VB6. Who's had the joy of being a VB6 developer?
Oh, yeah.
Oh, wow. That's a lot of people. And we've not all ended up in an insane asylum. That's quite impressive. So when I first started writing code using VB6, I loved this kind of increase in ability. I loved the fact that I could drag and drop things to create a user interface. I love the fact that I could express myself really well. I love the fact that we were starting to get object orientation concepts in there. And I just made everything using VB6 for quite a few years. And my first professional job was using VB6 as well. This is where my one and only claim to fame in the world rests. Who remembers IRC? Cool. So, for those of you who didn't put your hand up, IRC predates Slack, Twitter, everything. IRC was the way that geeks talked to each other in the 90s, in the 80s and the 90s. And a friend and I wrote the second most popular IRC client. So my claim to fame is that I wrote the second most popular. I bet you thought I was going somewhere else. No. So a friend and I wrote IceChat, which was written in VB6. We wrote a protocol-based IRC client in VB6, and it was the second most popular. I just like saying that because, claim to fame. So I got really interested in technology, complete geek as a child, spent all my time learning how to code. So of course when it came to considering what university course to take, I chose to do software development. Pretty obvious. I was so passionate about technology that I decided to do it as a career, and so I wanted to do it as a degree. But because I'm also by nature quite lazy, I chose every single module at university, which meant I didn't have to have an exam and I could just do coursework. So I could basically just do my work whenever I wanted. Which meant, of course, I spent all of my time studying. Spent all my time playing games. Does anybody recognize this game? It's not Counter-Strike, no. No. Predates all of those. It's based on the Quake engine, Wolfenstein Enemy Territory. I played so much of this game. I failed one of my modules and had to retake it. And I remember I stayed in university accommodation with my friends. And I remember thinking at one point, having a conversation with my parents about how if this was the life of a software engineer, I couldn't wait to start working. Playing games all the time, coding some of the time. I was so excited to get out there and get into the professional world. So, like I said in my intro, I'm originally from the UK, and my first ever job that I got paid to write code was working for a local government, my local government in the UK. And being the UK, we have amazing offices. This was the local government office for my local town. This was where all the office workers went that worked in the local government. Except IT. IT was in the Margaret Thatcher 1970s block down the road. False advertising. So my first ever job, being paid to write code, I worked in what was called the Geographical Information Systems Department. So this was effectively aggregating data based on location. So this was taking census data, this was taking information that the equivalent of the ABS in the UK put together, and it was all about providing information for local councillors. So local councillors could say, okay, you know, what's the age range in this area, what's the affluence in this area, so that they could make the right calls in terms of policy. The specific piece of work that I did was plotting all of the brothels in Bradford. Interestingly, they're not where you think they are. We can have this conversation at lunch. I'm not going to derail too much, but they're really not where you think they are. Okay, anyway, so I was so excited. I finished my university degree. I'd ended up finding this job for the local government, working on great, as a 21-year-old, really, really interesting data. But I rapidly realised something. I started my job, first professional job, and a week passed, and I wasn't writing any code. 2 weeks passed. I wasn't writing any code. And I started thinking to myself, is this normal? Do they not trust me because I'm a new developer? Maybe I don't have the skills. Maybe I was completely wrong in my self-assessment of where I was. But I just wasn't writing code in this professional software engineering job. So what was I doing? Bit of writing code. Configuring everything. Configuring the databases, configuring the servers, configuring automating parameters, doing testing, learning new libraries and frameworks, and of course, the things we love the most in the professional world, meetings, after meetings, meetings to start off a project, meetings to end a project, meetings to discuss architecture, meetings to discuss meetings we've just had, meetings to discuss meetings we're about to have, meetings! And I just started getting 3 months past, 6 months past, and this was my face. I didn't understand why I wasn't writing code. I was 3 months into my job, and I still hadn't written a line of code. I actually started feeling a little bit ashamed because I didn't understand what was going on. I thought, they're just not going to trust me. What? It must be me. I must not be good enough. They must not be giving me the work that I want because I'm not a good enough coder. And they must see something in me that I don't. There must be something in me. And I started seeing everything that stopped me doing the real job as something that had to be rushed, as something that had to be done as quickly as possible, as poorly as possible, just to get it out of the way, so that I could prove myself, so that I could show them that I was the coder, that they would let on the tools to write code. I never convinced them, or so I thought. And actually, I ended up leaving that job because I was frustrated by this supposed lack of progress that I was having. And I'm just going to put that story to one side, and we'll come back to that in a minute. Because I left that job and I went to have another job. English people in the room, do not answer this question. Does anybody not from England recognise what this contraption is?
Pants presser.
Say that again?
Pants presser.
Pants presser, trouser pressers we call them in the UK. Has anybody even heard of one of these? No. This is a uniquely English invention. I love these things. So if you go around all of the hotel rooms in the UK, there'll be one of these in a little cupboard somewhere. So that when you're a businessman going on a meeting, you can take this trouser press out, and you can press your trousers, so you can get that razor thin line down the front, so that when you go into the meeting, you look all smart and proper. Uniquely English invention. So I worked for the company that built these things. And I was the only software engineer in the whole company. Literally. This is me, 22 years old. And I'm sure we all know what we're like at 22 years old. We think we know everything. I've just left the job where I wasn't able to do what I wanted to do, and I was raring to write code and get stuff done. So I was excited about this opportunity to be in a company where I was the only software engineer, and I could just build everything. Luckily for me, I had a great mentor on what it means to be a software engineer in this company. But notice I said I was the only software engineer. My mentor was the operations director, the guy that managed the warehouse. He was an electrical engineer by trade. He didn't know anything about technology. He was an electrical engineer. But he taught me that the principles of engineering, be it mechanical, electrical, or software, can all be applied together to build software in a way that makes sense. So the same concepts that he was using with the electrical engineering and mechanical engineering to physically build these trouser presses, he taught me how we can apply these same techniques. So, getting code into modular reusable parts, building a production line. And I loved it. I learned so much about the process of software development from an electrical engineer. But there was one thing he did which I really, really value to this day. Every time we were going to write a new piece of functionality, every time we were going to add a feature to the system, he would have me doing the job that the code was going to help before I wrote the code. So, I would be there in my skivvies, in my casual clothes on a weekend, packing stock, unpacking stock, placing orders with the factory in China, putting things onto the back of the delivery trucks. Every time I would do a new piece of code, I would do the physical job before I did that. And it was around this time that I had an epiphany about the last job I was talking about before. I started realizing that all of those things that I hated doing in that last job were all driving me towards one particular view of what it means to be a software developer. And that view is that it's not about the code. It's not about the technology. This is my definition of what it means to be a software developer. And this is the epiphany I came to. The job is not to write code. The job is to solve business problems. Who said about solving problems? Yeah. Solve business problems and or provide value to end users. Sometimes, when I'm doing this talk for open source people, I remove that first line. But in reality, at the end of the day, if we think about it, when we're writing code, if the code we're writing doesn't solve problems and doesn't provide value, then we're not going to get a paycheck very quickly. Because if we're not providing value to something, we're not solving problems, then your company is not going to get paid by their customers, and then you're not going to get paid by your company. So this has to be the answer. This has to be the reason why we get that paycheck at the end of the fortnight. Because if we weren't doing those things, we wouldn't get a paycheck. If we just wrote code that helped nobody, we wouldn't get a paycheck. By the way, when I started my visa application process to come here, I had to talk to all of my previous employers. This company, I worked for them 11 years ago, and the software that I wrote 11 years ago is still being used. Probably shouldn't be. The code that was written by a 22-year-old junior software engineer probably shouldn't be used 11 years later. It's just a horror story for all the new software developers in the world. So I had this epiphany, and I realized that this was my definition of what it meant to be a software developer. And so when time came to move on from this company, I started looking at new positions and new opportunities. I found an amazing place to work. This place. I got the great offices. But, and there's always a but, where do we think the IT offices in this amazing building are? If I just kind of look up, I can just about see the sky. Yeah, but it still was an amazing place to work. And there's one thing that's probably a little bit contentious about what my role there was. Let's see if we get any groans after I go to the next slide. This was my job title. That last word, ooh, consultant. This is what people think of when they think of consultants. Shiny suit, shiny smile, clipboard. If you ever want to laugh, Google image search consultant. It's great. Shiny suit, shiny smile, shiny clipboard. Shiny suit, shiny smile, shiny clipboard. This was my job. It was being a consultant. And for me, what being a consultant means is maybe not what it means to a lot of people. For me, being a consultant meant really deeply understanding the business problem we were trying to solve and talking to people about how we were going to solve that and what the right way to solve it was and if we should even solve it in the first place. And it kind of put together all of these things that I liked about the software development process. Because at the end of the day, if our job is to solve problems, not write code, then we should be focusing on the problems, not the code, at least some of the time. And it wasn't until I did this job that I really realized that I actually quite like talking to people. I used to be the person that played phone tag or phone chicken, you know, where the support phone's ringing, and you're like, you answer it. No, you answer it. No, you answer it. Just so you could be the last person to pick up the support phone. But I realized in this job I actually quite like talking to people. And I liked understanding where they were coming from, and that kind of ultimately led me to where I am now, which is talking for a living. And it was during this job that I kind of started putting together a model of what it means for me to be a software developer. And this is my model. And we'll go through it. But effectively, there's a list of things that we do before we write the code. Then we write the code, and there's a lot of introductions. A lot of this is going to be very, very familiar to you. But interesting, a lot of these things are the things that I said that I hated doing in that first job I ever had. Talking to people, designing and architecting, testing, documentation. These things that I said I wanted to get done as quickly as possible. I started realizing the really important value that they added to the software development lifecycle when we change our focus away from the code and onto the problems. Let's talk about some of them. Let's talk about the first half first. Communication and talking to people. It's not always the software developer's best friend is talking to users and talking to customers and, interestingly, doing sales. Weirdly enough, I love doing sales as a software developer because I'm really, really proud of the code that I write. I'm really proud of what I produce. And I'm going to be paid to go and show off. That sounds pretty good to me. If I'm proud of something, I should want to show it off. I should want to demonstrate to people how proud I am and how fun it is to do this showing off. And when we look at it from a kind of point of view of how much this helps companies give confidence to clients, how much it helps win work, actually having somebody in the room who knows what they're talking about is kind of a good thing for a sales process. And how many times have we been handed a specification and said, implement that, and you go, no. Most of the time that happens is because there wasn't a technical person far enough back in the process to cut that off before it started. And it's because we quite often don't like to be in the rooms, quite often don't like to do these things. But if we don't like getting that specification that isn't implementable, we should be accepting the trade-off of maybe we need to be better back in the process. So yeah, I love doing sales. I really, really do. I'm a huge show-off. Testing. Ooh. Sorry, thinking. Testing comes next. Thinking. For me, when I think about thinking, that's very meta. When I think about thinking, I'm kind of going into critical thinking mode, and I'm saying, quite often we don't seek to validate our own assumptions, and we don't seek to validate things that we hold to be true. And that's a great transition to us being here today. And this is exactly the kind of thing that going to talks that we otherwise wouldn't have gone to go, okay, well maybe I need to challenge my assumption on something. If you look at a talk and it makes you feel a little bit uncomfortable, you should probably go to it. Because it's going to challenge your thinking in a way. And you might end up the other side of the talk still feeling the same way. That's fine. But at least seek to challenge your own assumptions. Design and architecture. My tendency as a junior engineer, and it's still my tendency now, although I try and stop doing it, is just open up my IDE and start writing code straight away. And to work the problem out as I go on. And what I've discovered is that spending time beforehand working out how to solve the problem always pays dividends at the end in terms of the time it takes to solve the problem. And obviously there's a law of diminishing returns in here that, having discussions before and not jumping straight into the code and trying to fully understand the problem we're solving and then discussing how we're going to solve it rather than just having this tendency to jump straight into solving the problem straight away. That's something that I did so much. Okay, so we spent some time talking to people so that we know we're building the right thing. We thought about how we're going to build it. We put a little bit of design and architecture into it. So if our focus is on solving the problem, we feel like now's the right time to write code. Yeah? Is it? Sometimes we think code is the answer to every single problem. How good is it if we can solve a problem without writing any code at all? Using an existing solution, using an existing library. Who's heard of or experienced the not invented here type scenario? Or that library is great, but it does 90% of what we need, but that 10% is really important. So we're going to spend 6 months building something ourselves. This kind of mentality is focused on the code. If this kind of shift that I'm advocating here is to try and focus on solving the problem. And so rather than weighing up the things that you were weighing up, does this thing solve the problem effectively? Does it add the value? And if it adds value and we don't have to write code, that's even better. It's less to support, less to test, less to think about. So quite often, one of the tendencies I had was always rolling my own, when we should be looking at reusing things that already exist. Okay, so now let's go through the things that are afterwards. Documentation. Ooh. Who loves documentation? Nobody. Oh, really? Oh, brilliant.
Yeah.
Yes. So, if we're reframing the job away from the code and onto solving the problem, then the way that I would reframe documentation is not to document the code. It's to document the decisions that led to the code.
Thank you.
It's this, how many times have we looked back on a piece of code and we know exactly what it does? We just have no freaking idea on why it does that. It happens all the time. And so, really focusing on why the code does what it does is much more important than what it actually is. Because if your code is, reasonably sensible, you can pretty much always read what it says. And to kind of justify and pump that point up, it's really, really interesting that code is almost a write-only medium. Because very, very rarely do we tweak and change code as often as we read it. And so investing more time to write readable code is going to pay back way more. All these things we do where we think we're being really, really clever and these 10 lines of code, we're going to turn it into one because we're using some clever syntax that nobody else in the company uses. This is all because we want to make the code as small as possible. But that doesn't matter because it's read 10 times more than it's written. So we should be focusing on code readability, not code writability. Often when we come back to the code, it's our own code, and we've also forgotten what it is. So it's not just about other people. I've read plenty of my own code and testing. Again, reframing from technology and code to solving problems. Testing. If testing is about solving problems, then the fuck it, ship it mentality doesn't work. Apologies for swearing. It doesn't work. We know it doesn't work. So why do we do it? Why do we ship things before they're ready? Deadlines.
Good enough.
Good enough. Yeah. Sometimes good enough.
Near enough.
Sometimes good enough is not good enough because the person making the decision on good enough is not the right person. And that's quite often what happens is we have a deadline and somebody goes, it's good enough, ship it. Technical debt is a real issue that we have to face as an industry, and this ship it mentality is just feeding into that. And ultimately, again, if we're going through this reframing process, then it's less important to ship it and more important to do it right. Because if we ship something that doesn't solve the problem, what was the point in shipping it? We ship some code, yeah. Companies that make you do this are not companies worth working for, because they're going to stunt your growth as a junior developer, or as a mid-level developer, or a senior developer, but especially as a junior developer. Getting that right habit as a junior developer is crucially important. And monitoring and testing hypotheses. This is a personal favorite of mine. If we're solving problems and adding value, how do we know if we solve the problem or add value? If we're not measuring anything. If we're adding value, how do we measure that? What measure can we use? If we're solving a problem, how do we know? So again, just shipping code and pushing it out there and walking away. How do we know if we've done the right thing? And these are where things that I'm sure you guys have heard of, like A/B testing, and getting analytics into your programs. This is why it's important. It's not important because we want to know if the code is broken or not. It's important because we want to know if we're solving the right problems in the right way for the right people and adding the right amount of value along the way. How do we know if this small change we made had a huge impact or a small impact? Without monitoring analytics, we have no way of knowing. Ultimately, how do we know if we're doing our jobs well? How do we know if we're being good at what we do if we don't measure it? I'm just going to go ahead. Okay, cool. So a little aside on this. Quite often we do this thing where we measure the thing that's easy to measure as opposed to the thing we actually need to measure. You can see this all the time. How many people have number of open bugs in their bug support system? It's a completely useless metric. But it's really easy to measure. Super easy to measure. Count star, job done. Rather than asking the question, what metric is actually the right thing to measure? What things should we be measuring? What things are actually improving our customers' lives and our customers' value? Rather than focusing on number of bugs, focus on number of successful journeys, number of journeys that had an issue, things like that. It's just a reframing of the things that are important to measure based on are we solving the right problems and adding the right value. learning, experimenting, and exploring. This is something that I am super passionate about. We should always be seeking to improve ourselves. We should always be trying to do better. We should always be on a path of growth and discovery. And in our industry, things move so quickly that we can quite easily be left behind. But I don't even think that's the reason why. I think we should be doing it because we can always solve the same problem better if we learn something new. We can always experiment. We can always learn a new technique now that when we come to the same problem we had a month ago can give us a better way of solving that problem. And this isn't about learning the latest unicorn poop.js or whatever the new flavor of the month is. It's about just having that growth mindset and that kind of ability to learn. Because at the end of the day, a good developer can always learn a new technique. A good developer can always learn a new framework and a new language. And this is why one of the things I rail against with my clients when we talk about hiring, how we hire developers with clients is getting a laundry list of features and then passing that to the recruitment consultant and say, hire that is terrible. Expecting that somebody is going to have 3 years of React.js experience, 2 years of Angular, all this kind of laundry list of features, that's not relevant. You can teach techniques, you can teach frameworks and libraries. What you can't teach is a growth mindset as easily. You can, it's hard. So finding the right people with the right experience and knowledge is great. Finding somebody with the right mindset is even better. Again, any company, if there's any junior engineers, any company that doesn't encourage learning and development for you as a person, they're not a company to work for. Because you're going to rapidly find your growth stunted by staying in a company that wants to use the same technologies and the same techniques for 20 years. Code reviews. Who loves code reviews? That's good. I did this talk 2 years ago. 2 people put that hand up. So we had more than 2 that time, then I wasn't looking. There's a guy called Peter Wilson who did a great talk on mentoring at the web meeting. If anyone knows Peter, he's awesome. And he said that his guilty secret is that he likes code reviews. I don't think that should be a guilty secret. I think it should be something we're proud of. Because again, if we're trying to become better and we're trying to improve our skills, then code reviews are an excellent way to do that. At the end of the day, we're not as smart as we think we are. There's always somebody who's smarter than you, and there's somebody with a huge ego that's really hard to accept. But code reviews is a great way for me to challenge myself. Having my code reviewed by somebody else helps with that ego quite a bit. And also, I've learned a lot by reviewing somebody else's code, looking at what they're doing and going, oh, that's pretty smart. I wish I'd thought of that. We're always learning when I review other people's code. In fact, when I learn a new framework or a new library, I look at what other people have built on GitHub, and I download their code and look at how they're using it. It's quite often better than the official documentation, because quite often the official documentation isn't solving real problems. It's just like a to-do list. Woo. Okay, so we're just coming to the end of this, and this is really my way of looking at software development. All of this is how I view the way we write code, and they're always equally important. We do the things we did before. We ask the question, do we write the code or not? And then we do the things after we write the code. And notice how this bit is just this tiny little section in the middle, and everything else is around the edges. And if our job was to just do this little bit, then that will be the biggest thing, that will be the most important thing. But it's not, it's this tiny little thing in the middle. Because without everything that surrounds it, without all this other stuff, this doesn't add the value that it needs to add. It's everything around that supports the value that this adds. So in the closing, I just want to mention this quote. I really, really love this quote because every time I read it, it makes me think again and again and again. So in the future, this is by Michael J. Flynn. In the future, everyone will be a software engineer, and barely anyone will know how to code. There's lots of ways to think about this. There's lots of ways we can interpret this sentence. One of the ways that I thought of, and I'd love to have other people's interpretations of this, one of the ways that I think about this is with the progress of AI and automation and machine learning, who knows if the job of a coder will exist in 20 years' time? The job of somebody actually typing on a keyboard and outputting code, I'm not sure that will exist in 20 years. Maybe 30 years or 40 years. But the ability for somebody to look at a business problem, understand if it's solvable and how to solve it and how to add value, and then how to translate that into something which can be built, that's always going to be there. Or at least for a lot longer than just writing code. Writing code is really, really fun. I do it as a hobby. But I think about it as the same way as a carpenter. I think about it as, at the end of the day, a carpenter knows how to use a hammer, but that's not why we pay them. We pay them to build a bookcase. And if they ask the right questions and build the right bookcase, we pay them more money than we pay IKEA to give us the bookcase. Okay. One last quote. I really, really liked how that looked, so I had to do one for myself. My worth as a software engineer is not in how well I write code. It's my ability to solve problems and provide value to end users. Thank you.